two ships are marked on a grid with ship A positioned at 4, 7 and ship B at -1, -8. Part A wants us to find the vector AB. For this question, we can quickly write down the coordinates of ships A and B in terms of the position vector. So OA is actually 4, 7 and OB is actually -1, -8. If I want to find the vector AB, which is simply OB minus OA, I will now substitute the position vectors of B and A to get my answer as -5 and -15. So my vector AB is given by this. For part B, a third ship is marked at C such that the vector AC is half of the vector BA. They want us to find the coordinates for ship C. So for this, I will simplify what we have. AC is equals to half of the vector BA. So vector AC is OC minus OA. And I will have half of BA from my answer in part A, which gives me AB. So BA is the negative of AB. I want to find the coordinates of ship C. So the position vector of C is half of the negative of vector AB, which will then be 5, 15, plus I have position vector of A, which is 4, 7. So my answer for OC is 6.5, 14.5. And then now I have to translate the position vector of C into the coordinates of C, which would be written as 6.5 and 14.5. So my answer for ship C would be like this. For part C, a submarine is moving parallel to AB with a translation vector 3n. They want us to find the value of n. Now, if the submarine is moving parallel to AB, I will be able to express this translation vector as k times of vector AB. Or you can do it vice versa. So 3n is k times of -5, -15. Okay, so we know that 3 is k times of -5. This helps us to find k. Okay, then we also know that n is k times of -15. So if we were to substitute the value of k, we will be able to get 9. So the value of n is actually equals to 9. Because the submarine is moving parallel to AB. Let's go on to question D. They want us to show that triangle OAB drawn on the grid forms an isosceles triangle where O is the origin. Now, if they want us to show a triangle, any triangle, okay, so I'm just going to sketch a diagram. Okay, so triangle OAB forms an isosceles triangle. Now, they did not tell us which two sides will actually be equal to form the isosceles triangle. So the only way for us to show that triangle OAB is an isosceles triangle is to actually find the lengths of OA, OB, and AB. So two of the sides would have to be equal for us to form an isosceles triangle. So the magnitude or the length of OA is given by 4 square plus 7 square. Take the square root. So OA is actually square root of 65. If I were to find the length of OB, I would get -1 square plus -8 square. And I take the square root, and I get square root 65. Then I do the same to find the magnitude of AB, which is -5 square plus -15 square. Okay, now from here actually you can see that the length of AB would definitely be longer than the other two lengths. But it's okay, we will write it down. And then we conclude that in triangle OAB, we actually have the length OA equals to OB. So triangle OAB forms an isosceles triangle.